A stealth aircraft, futuristic in shape, no tail, silently flying and controlling a fleet of drones from the skies. The question is simple. If such an aircraft is truly ready for use, what does it signal to the global air power landscape? Today we'll look at its technology, design logic, and evolutionary trajectory, including one sixth-generation aircraft candidate, the J-36, and most importantly, what strategic signal it might carry for global air power. Over the next few minutes, we'll explore how this aircraft is designed without a tail, how it could serve as a drone control center, how it relates to other sixth-generation programs around the world, and most interestingly, is this just another technological evolution or a sign of a major shift in the global air balance? Stay until the end, because the further we go, the clearer the bigger picture becomes. Part 1. The Aerial Paradigm Shift. This is where our discussion begins. In the past, air power was synonymous with speed, number of aircraft, maneuverability. But now new parameters have emerged. Who has the smartest network? Who can control drones most effectively? Who can process data the fastest? If the J-36 is truly positioned as a drone control center, then it's not just an aircraft. It's a central node in an air combat network, and this is signaling. Part 2. The global context. In other parts of the world, similar programs are being developed. There are sixth-generation platforms often mentioned, the NGAD program, the Tempest project, and several other initiatives. This means this is not a one-way race. It's a global competition towards a sixth-generation air future. Part 3. Signals of a power shift. Now, we come to the big question. Does this signal a shift in global air power? The honest answer: we don't know yet, but the signals are strong. Because a sixth-generation platform isn't just an aircraft. It's a symbol of high-level technological readiness. It demonstrates mature industrial, digital, and engineering capabilities. If one side moves faster toward sixth generation, while the other is still adapting, then the balance could shift. Slowly, but surely. Intellectual conflict. Imagine this. In the sky, there's a tailless stealth fighter. It's not alone. To its right and left, combat drones. All connected, sharing data, locking on targets remotely. Whoever controls the network will probably control the skies. This is the intellectual conflict. Will the future of air combat still be determined by pilots or by algorithms? Technology insights, facts, technical performance, and speculation. Several sources mention potential speed of Mach 2 or more, maneuverability supported by thrust vectoring, possibly AI-based avionics, long-range communication capabilities, and integration with autonomous drones. But important, much of the data remains under wraps. That's why we're separating them. The facts: prototype, sighting, tailless design, rapid development, collaborative drone concept. The interpretation, performance details, real combat capability, operational readiness. Everything is still subject to change. Analysis: why is tailless so important? Modern radars are increasingly sensitive. Airspace is increasingly dense with sensors. Survivability is a top priority. Tailless equals less radar reflection. And when combined with radar-absorbent materials, the result can be extremely difficult to detect. But the cost is high. Engineering complexity increases dramatically. Only a few in the world can afford it. Facts: development status. A second prototype has emerged. There are design changes. It's likely to test different configurations. This indicates a rapid experimentation phase. This iteration speed demonstrates strong resources, high focus, a long-term roadmap. What is really being achieved? Various analysts see the primary goals of the sixth generation as information dominance, stealth superiority, Beyond visual range, combat capability, human-machine integration, aircraft are no longer just tools. They are becoming airborne command platforms. If these goals are achieved, then the global airscape will change forever. Part 4. The 6th generation technology background. Let's start with an overview. The world of combat aviation has now entered a new phase. After the widespread recognition of the 5th generation, the focus is now shifting to the 6th generation. Features that frequently emerge in discussions of this technology include increasingly mature stealth capabilities, data-driven combat networks, human-drone collaboration, artificial intelligence for decision-making, and the ability to defend and attack at greater distances. This generation isn't just about speed. It's not just about maneuverability. It's about who controls the skies and also information. Part 5. The emergence of the J-36 platform. One candidate currently being widely discussed is the platform known as the J-36. Some key points reported. Prototypes have been spotted conducting test flights. Futuristic, tailless design. Rumored to have the potential to function as a combat drone command center. Even considered a challenger to other 6th generation programs being developed elsewhere in the world. One prototype showed indications of thrust vectoring. This technology allows the aircraft to maneuver more flexibly. And most interestingly, development appears to be moving quickly. Part 6. What does a tailless design mean? Now let's analyze it. Calm down. Slow down. A tailless design isn't just a futuristic style. The vertical tail is one of the most radar-detectable parts of an aircraft. Removing it means reduced radar signature, increased stealth, but more complex flight controls. This means that controlling an aircraft like this requires highly advanced control software, next-generation fly-by-wire systems, computer-based stability. This isn't a small leap. It's a technological leap. Part 7. The role of command and control. This platform is also reportedly designed as a drone command center. The concept is simple yet revolutionary. One manned aircraft, surrounded by a fleet of combat drones. These drones can conduct reconnaissance, distract attention, even attack specific targets, while the mothership acts as the brains of the air operation. This is known as the loyal-wingman concept. Part 8. Evolution from Generation 4 to 6. Before we get to the 6th generation, it's worth taking a quick look back. The 4th generation focused on speed, maneuverability, close quarters combat capability. Then the 5th generation added stealth, sensor fusion, long-range combat capability. Now the 6th generation takes it even further. Human-drone collaboration, artificial intelligence in decision-making, data-based operations. This isn't just a performance upgrade. It's a shift in the philosophy of air combat. Part 9. Why command and control matters. Let's talk about the role of the Air Command Center. In this concept, the pilot doesn't just fly the plane. The pilot becomes the mission manager. The drones perform high-risk tasks, while the mothership maintains a safe distance, processes data, and directs operations. The advantages are clear. Increased pilot safety, tactical flexibility, wide area coverage. This allows a single aircraft to have the power of several fighter jets at once. Part 10. The role of AI and data. This is where technology truly takes the next level. Artificial intelligence plays a role in monitoring airspace, sorting information, making decision recommendations, even assisting with navigation. The greater the volume of data, the more powerful the aircraft. Because in the future, the winner won't just be the one with the fastest weapons, but the one who understands the situation the quickest. Part 11. Engineering challenges behind tailless designs. But tailless designs aren't without risks. Without a vertical stabilizer, the aircraft is more difficult to control manually. Therefore, it requires highly precise flight control algorithms, sensors capable of detecting changes in air pressure, redundancy systems to prevent failure, This demonstrates one thing. The sixth generation isn't just about the airframe, but the digital technology ecosystem that integrates it. Part 12. Comparison with other global programs. If we look at the global map, several sixth-generation programs are trending toward a similar pattern. Radar signature reduction, drone collaboration, AI integration, remote operation. It's as if the world's engineers are unknowingly pursuing the same solution. What does this mean? That the technological direction is clear. The future of the skies will be controlled by networks. And whoever meets these requirements the fastest will be one step ahead. Part 13. Economic and industrial impact. Now, let's talk about the industrial side. Building a sixth-generation aircraft means massive research investment, a high-tech industrial supply chain, hundreds if not thousands of engineers involved. This is no small project. It's building an ecosystem. And when a country is able to produce a platform like this, it demonstrates the technological maturity of its industry. Part 14. Pilot training and new doctrine. Technological change means changing doctrine. Sixth-generation pilots are not just pilots, but network systems operators. They must understand AI, manage companion drones, interpret vast amounts of data. This is changing training standards and, indirectly, changing the way modern air forces operate. Part 15. Not just machines, but ecosystems. What is often forgotten is this. Sixth-generation aircraft do not stand alone. They are connected to satellites, drones, ground radars, warships, digital command centers. This makes aircraft not just defense equipment, but nodes in a vast network. Part 16. Operational time and reality. But there's one thing we must always remember. A prototype doesn't mean it's immediately operationally ready. The stages are lengthy. Structural testing, avionics testing, weapons testing, system integration testing, certification. Each stage can take years. So even though it seems like rapid development, the operational readiness period still goes through a rigorous process. Part 17. Ethical dimensions and the future. There's one big question. As AI and drones become increasingly dominant in the skies, where are the limits of human control? Because ultimately, technology is just a tool. It's still the humans behind the system who determine the direction of its use. This makes the discussion about the sixth generation not just technical, but also moral. Concise, neutral, professional conclusion. Final part. Let's draw a straight line. There's a sixth generation platform. Its design is tailless. It can work with drones. It's being developed rapidly. On the other hand, similar programs are underway in various parts of the world. This is no coincidence. This is a silent technological race. And every step forward is a signal that the global climate balance is shifting. Not today, not tomorrow, but the direction of the shift is beginning to become apparent.